Yeah, so this is lecture 3. So a couple of clarifications before we proceed. So there were, I made some errors in some of the uh, specs and in the last lecture. One was, I referred to the audio bandwidth as somewhere in the region of 10 kilohertz. More exact solution, more exact spec for that is 24 kilohertz, right? Even if you 10 kilohertz kind of takes up most of the energy of an audio signal, but if you have to transmit high fidelity audio, the specification is 24 kilohertz. You allocate the 24 kilohertz bandwidth for baseband bandwidth for transmitting audio. That is one. And number two, there was a question I think Dhruv had asked that why do we have 50 ohm impedance for antenna? Why do we consider antenna impedance to be 50 ohm? The reason I gave was it is equivalent to the free space impedance. Again, it is related, but it is not equivalent. As it turns out, the exact free space impedance is higher than 300 ohms. But the reason it is 50 ohms has some other reason. So as it turns out, you need, I mean, even when you are routing something on a PCB or you are connecting to two blocks, you need to do it through an interconnect. And one of the most efficient or the commonly used interconnect is a coaxial cable. Have you seen coaxial cables? So it's a conductor with the inner with a, you can assume it's annular ring with a center core and an outer core. It's a cylinder, a small cylinder inside and the big cylinder outside, overlapping it, and in between you have a dielectric. So and typically the outer ring is grounded and the signal travels to the inner cylinder. So as it turns out, when you decide to transmit signals through coax, there are certain trade-offs. So if you take the trade-offs between the breakdown voltage, the power loss, and what else? Breakdown voltage, power loss, and if you increase and power delivered, right? So the maximum power that you can deliver, assuming some impedance of the coaxial cable, the loss per unit length of the coaxial cable and the breakdown voltage of the coaxial cable, it becomes a interplay between two levels of impedance. If you do the math for a coaxial cable, it comes out to be either you choose 77 ohm or 30 ohm or 36 ohm, somewhere in between. I mean, in between these two limits. So historically, which people say that we don't want to do all those things. We will basically take the average. The average comes out to be around 50, and that's what stuck. So if the coaxial cable impedance requirement is 50 ohm, and then coaxial cable connects typically on one side antenna, other side a receiver or a transmitter, or whatever. You have a block, we have two blocks connecting coaxial cables, and just to ensure maximum power transfer, or basically, I haven't talked about matching in detail. We'll talk about matching in detail, but if you let's consider that we want to ensure maximum power transfer between blocks connecting the coaxial cables. So we have to ensure that all of them have similar impedances or same impedances. So which means that if one side is connected to an antenna, we can make it 50 ohm. If other side is connected to some block, we try to make it 50 ohm, right? But again, this 50 ohm is nothing sacrosanct. It comes from some other requirement. So for example, if you have an antenna inside your chip, right? If you have a very high frequency antenna inside your chip, you can do away with the requirement of 50 ohm. You can design an antenna for some weird impedance that you like, and you can do away with the 50 ohm. But if you are designing a block, which you know will be connected to something on the board or something else, which another vendor is going to use, then you will have to keep some standardization. It's like why all our plug points have the same 3-pin and same voltage rating and same mechanical supports, right? It's because because of standardization. So similarly, for standardization reasons, we keep it to 50 ohm. So a very good explanation of it is there in Professor Thomas Lee's book, right? One of the reference materials. There's one section on it. You can read it up, and he has explained it very beautifully. Okay. Okay. So with that explanation out of the way, so let's proceed. So we were discussing the power amplifier, right? So we had a mixer. This was some V in T. These are the baseband. These are the frequency component of